All right, and with that very short break, I'd like to welcome Vishnu to the stage. He's going to be talking to us about gaining composure. So without further ado, let me welcome Vishnu. And we'll get right into this talk. Again, just a reminder, there's a Slack channel specifically for asking any sort of questions. Use the question emoji to preface those so it's easy to find them, and we'll answer those questions live for you after the talk. Without further ado, here's Vishnu.
Cool. I can be everyone. You can hear me correct? Gonna go with yes. Cool. So let's make sure that my clicker works. Nice. Awesome. So I'm here to introduce you to your hour of Compose. I believe the talk right after mine is Compose as well. This talk is going to be a short one. It's a 20-minute, but it sort of assumes that you have some general experience with Android, of course, but also that you kind of understand, not even understand, you kind of know what Compose is. It's a new UI toolkit, how it kind of works towards reactive UIs, and just that it is quite different from what we're used to. But off the top, I just also want to make sure that I thank Chicago Roboto for actually doing this. This is pretty awesome that we made this happen. And this is probably the most interesting way to get rid of the pillars at the Ches that I've heard of. So good on John for making that happen. So yeah, we're going to talk about a few things related to Compose. Specifically, a lot about how it works dynamically and sort of rewards the building of dynamic UIs and unidirectional data. And so what we're going to cover are, to start with, some of the smaller stuff, like a view, specifically making a very small view component, and how we make that dynamic. We'll go bigger from there to a screen, and then we'll sort of exit the rendering pipeline, and we'll talk about how you can kind of organize your code and dependencies so that your components can talk to other components in your application. So a little bit more of the plumbing and less of the rendering. So right off the top, talk about the views. Folks know how our current views work. And so I'm sure a lot of folks have felt pain when trying to make existing view components dynamic. And so what we're talking about there is that like the user input or data input or like the environment changes in some way. And we want to make something as simple as a button react to that change. You'll end up with sort of a convoluted code base, or you'll end up doing very bespoke architectures to work towards this sort of reactive UI. And so here we've got a very simple composable. And so just as a context, a view component in Compose UI is called a composable, at least for the for this talk. And so here you'll see that we have a very simple extended floating action button. It tells the user, here's what you can do. When you click it, it does it. We're not doing anything exciting here. Takes an on click, displays some text, has a color, etc. So we can consider this a single state. One of the main cool things with fabs or floating action buttons is that they are kind of built to be dynamic. Oftentimes you'll see them switch from a plus to a minus, or disable themselves, hide as you scroll, etc. And so that's what we're talking about when we talk about dynamics. And so let's say we wanted to add a single state. Rather, let's say we wanted to double the state from single to double. Here we're talking about a Boolean. So this flag will let us know in the component level whether we should let the user create a new note or not. And so we don't really want to hide it. We don't want to disable it. Let's just say this is what the designers have chosen, and it kind of makes sense to us. We want to let them know that they can no longer create a note, but we don't want to hide it and make it so it's confusing, like where did my button go? And so we've added this flag, and it's just a Boolean. And so we'll start to use it. We'll add a new type of text. and we'll then add specific handling on how the click works. So if we allow creation, onClick fires. If we don't allow creation, let's not fire it. We may want to maybe in the future add a toast, but let's just say for now we don't want to do anything. And then we want to change the styling. And so based on whether it's allowed or not, we want it to be green or red. In this case, secondary or error. Those are values that are set up in your material theme, which is another portion of the Compose UI. You can use, of course, use other values, but let's in this case just use secondary and error for the background, and then on secondary and on error for the content color. And so here you have it. Here's your new state-ready component. And so what does this actually look like? Because so far I've been showing the same button up top. It's been green, it shows add new note, hasn't reacted at all. And so when we were calling this fab, let's say we were passing in true the whole time, what does it look like when it's false? So what you'll see is that it turns red, shows maximum notes. It's very simple. This isn't like a, I wouldn't say this is a very complex entity, but it's still two states. And as you start adding states, this becomes more and more complex. And that leads us into like, how do we see these state changes? Because maybe this state is dependent on like a very bespoke route of actions. The user's in an enterprise who is owned by so and so, and they have these specific limits, and you don't want to really drill into an app with those specific user sets that can trigger this state. And so the Compose toolkit has a layout preview system, and so we will take advantage of that. So we add an app preview. What this does is it tells the layout preview to just render this composable. But because we've got a parameter here without a default, it doesn't know what to do for it. It doesn't really go in there and introspect like this is a Boolean, so let's give it 2 Booleans. Because if it's a string, what will it do? And so we'll add a provider. So this is something that's given from the toolkit. And you provided a sequence of values. In this case, in Booleans, you're really going to do true and false. If it's ints, you can give any number of ints. But it also works for custom objects and custom data classes, of course. So you would pass in various types of, or various instances, of the values that you want. And then from there, once we've written that, we will annotate that one parameter that we want to be provided by the class we previously wrote. So what this actually does, it tells the preview, use the sequence from the annotation class and be like, give us a true and give us a false. And then I'm going to use those values to render. And so what we end up getting once we've written all of this is we get this. So what we've got here is we've got both of our states visible with enabled 0, enabled 1, so you know exactly what's going on. And then you have 2 buttons there, which are really cool, actually. The left button with the little finger lets you do an interactive preview, so you can click it in your IDE. And the right one actually lets you launch a really small application to your device. And this application will contain just the button. And so you can play with it on there, and if it has other effects and stuff, you'll see it happen. So that's a good way of showing off some dynamic handling in view states. But let's go one bigger. Let's go to screens. And so it's not really bigger in terms of complexity, but it's sort of a bigger real estate. And the way that screens can diverge can sort of add an insane amount of complexity. And it's rare for us to really have a static screen. We might have our licenses screen, which will just be like a list of licenses. But oftentimes it'll be based on network. It'll be based on what the user's input or what another user's input. And so that's where the screen state becomes dynamic. And so this will work a little bit different from what we're used to with the XML view system, which for now, let's say you had a screen that's super static, takes a list of notes, shows it. This is, of course, hiding the fact that we've also written XML for the recycler view. We've written things to bind it to the layout manager and the adapter. We've written an adapter. We've written a view holder. And so all of that, but at the end of the day, we call submit list with the list of notes. And so this will show us our list. And now we get the request, hey, folks, we're seeing that in production that this takes 1 second, and it's weird. It's a blank screen. So, okay, let's add progress. So our view state, we give it a loading flag, and then if it's loading, we show a progress bar. And if it's not loading, we'll show the lists. But what you see here is that we now have to like toggle the progress bar on for loading and off for not loading, and then we toggle the list gone for loading and not gone for not loading. And we've already like increased the complexity, and this is just two states. And so what happens if we had a third state? Glad you asked. And so here we see yet another request, which is to show an empty. Maybe we want to like let the user know, hey, add a note. It's cool. But once again, what we're not talking about here, what we're not showing on screen, is that in actuality we have an XML file that has all three of these states fully described. And there's other attempts to, of course, deal with this. You can work around in other ways, swap in views as you want. But oftentimes you'll find that you've described the full possible superset of states in your XML, and then you get into your view binding code, and you toggle things on, you toggle things off, or you'll react differently based on the state of your model. And so here you see that we've got three states with four things happening in each, and if we add another state or if we add another view, what we'll get is you can get bugs here, like, oh, I added the progress bar, or I added a fourth state, but I forgot to toggle the progress bar, and that's where you get that weird look where the progress bar is floating on top of the whole content, or the empty state keeps showing up randomly. And so that becomes the real issue when you're trying to do dynamic screens, is that you have to keep all of this mental overhead in line in code. But really, you don't need to. I mean, you shouldn't need to, right? Like, what the screen should look like in each state. You have the designs for it, so why can't you just describe that directly, rather than describing them all? And so that's where Compose tries to get in, and it tries to say, let's just say exactly what we want per state. So if we're loading, we only want a progress indicator. We don't really want to care about, what is the empty state. We don't really want to care about, what happens if there's notes. Really, what we want to do here is just show a progress indicator until we're told not to. And then when we're empty, get rid of the progress indicator, and let's just show, in this case, something very basic, text that says no notes. And when we have actual items, let's show it in a list. And so here what we've done is we've described all three states, and it's all built off of the same model, this view state model. But we're not having to like track whether or not we need to turn on the progress indicator when we're loading and when we're not loading, and stuff like that. On top of that, we get to use this cool composable lazy column for, which I really suggest you go play with, because this is the adapter, it's the view holder, it's the recycler definition, and the layout manager, and it kind of just spoils you in writing recycler views ever again. It's a lot of fun. But it's just kind of another example of where this toolkit has put everything in one place, so you're not thinking about multiple things and keeping that mental overhead. And so there you have it. That's a dynamic screen showing three different things. And so let's talk about the third thing here, which is a little bit more plumbing, a lot less rendering, but passing dependencies. And I don't mean this like dependency injection, service locator, etc. But essentially, when you're writing something, it needs to interact with other components. And those components need to get passed to your view, your like composable or your view in some way. We currently might inject it into a top level and then pass it down, or we'll inject it and we'll use it right there. But some way or another, our components need ways to talk to other components of our application. And so one way, and this is one of the ways that the framework uses it, the Compose framework specifically, is a system called ambience. And so Compose has taken this idea of ambience, and what it is, it's essentially like a common way of getting things. It's not all pretty, it's not all amazing, but let's just talk about this specifically. In this example here is how you get your context, for example. There's a context ambient provided by Compose UI, or maybe it's the toolkit somewhere, but it's provided, and you call current when you're in a composable, and that gets you your context. And then you can use it, and you can do this yourself. Let's say you have a data modifier, and so you set this data modifier ambient in a top level. It's a val, and then you give it a default, or you can give it a null. There's multiple ways of doing this. And then in the entry point to your composable screen, you provide it. So in this case, we're providing it from our graph, but maybe in test we would provide it from like a fake, or maybe we provide it from like a different configuration based on our build flavor or something. Whatever it is, we would provide it, and the next time that we want to use it, we would call data modifier ambient.current. We get an instance of it, and we use it. So in this case, you can see this component has grabbed it from the ambient, and it's using it. And so that's one way to do it. There is some concerns around this that you would have to keep in mind. Ambients are essentially hash tables, or like, yeah, they're hash tables, and they're built on the signature of the class. And so you can see a world where like you put a bunch of stuff in ambience, you're really excited, and then all of a sudden you've essentially got like a static accessor to a lot of stuff, and you don't really want that because you're confused about where the instance come from, or like you just have too many ambients. So you're just like, how do I deal with this? And you kind of want to keep this one limited. There's not much value in passing everything through an ambient. You might find a lot more value with stuff that's like global to that screen. In this case, maybe multiple components need an image loader, or a data modifier in this case. And so you might pass those as an ambient for that screen specifically, but not global to the application. So there are some things you need to be careful of there, be wary of, but it's one cool way to pass dependencies. But there's another way, and it's really cool because it's been around forever, because composables are functions, and they're really just regular functions. It means you can treat dependencies as normal parameters. So just treat it like structure injection or calling a function. So in this case, we'll pass the data modifier in through the parameters, and we will just do that. And so this is a very interesting way, because you think, well, I got to pass this down all the way. But what happens is you sort of it rewards a unidirectional system. So you're going to have every compose screen is really going to have, I want to say, on average, two sort of things. There's an input and an output. So you're going to get data in from somewhere, and you're going to pass actions out through something. Those actions could be specifically like actions, or in this case, we're calling like a modifier. And this means that you really don't have to juggle like 30 things. You're not passing in like 8 repos, or you're not calling from databases directly. And so what you end up getting is a screen that sort of just plugs into your two ports, your input and your output. And as you start building it this way, your components that need to register to the input or register to the output, they end up doing okay, because they just get the parameter passed in and they use it. Other components that don't need it don't get to. If they need it, they add it to the parameter list. They don't grab it off an ambient. So it's a nice way to sort of restrict access to those dependencies. And so yeah, so that's pretty much how you quickly pass dependencies through composables. And so that's it. That's about a quick 20-minute run through on some rendering stuff and some of the plumbing. There is a lot of stuff now. So this was originally the idea for this talk had come out back in January, but there's a lot of stuff from the team. Leland from the team is doing like live casts, and then there's like blog posts and code labs and all that stuff. So I do highly suggest playing with it, and it's definitely something that you need to play with to truly understand, because it's almost too different to just sort of read and absorb. So yeah, thank you.
All right. Thanks so much, Vishnu. That
Yeah.
was really informative, and I'm sure it was interesting to propose a talk back when all of this was unknown and still developer preview, and then get to actually present the talk after after public alpha release.
Yeah, it was a interesting stick thrown in to find the like stuff that, because now that there's so much information to pick from, it was to find the specific interesting things that I wanted to talk about. But it came out okay, I think.
Yeah, yeah. I really enjoyed that, and I'm sure a lot of other people did too. The links, we'll share the links that you did at the end of the slides in the day one Vishnu
Yep. I'll post the
Slack
slides in there
channel.
too.
Yep. And we don't have any questions in there right now. If anybody has any questions, drop them in there, and I'm sure Vishnu will be around and happy to answer any questions.
Cool.
Otherwise, we've got about 9 minutes until we're ready for some more Compose talk with Ben. So grab your coffees, heat up your lunch, whatever you need to do, and we'll see you back here then.
Cool.